Hello everyone, can you hear me? Good morning, good lunch, good afternoon, and good dinner. Today, we are going to read Intermediate Python by Muhammad Yusuf Yula Khalid. Hello everyone, this is your Hacker Cyan. Welcome to the stream. Hello Taylor, hello Adam, hello Jupiter, hello Ransom, hello Ice Cat, hello Bear Child, hello Warrior-san, hello Chill Rocket 24, hello Milai, welcome. This is Cyan's first time doing read a book, so if there's any issues with audio, please let me know. Welcome Lord of Music, welcome Reckless. You can find the link for the book in the pinned chat and also in the description. Welcome Max, hello. 今天也有一点不大一样，因为要做以前没有做过的事。So if everything is if everything is okay, I'm going to go ahead and start with the preface. Hello 沈老师，欢迎。The title is Intermediate Python. Preface. Python is an amazing language with a strong and friendly community of programmers. However, there is a lack of documentation on what you learn after getting the basics of Python down your throat. Through this book, I aim to solve this problem. I would give you bits of information about some interesting topics which you can further explore. Topics which are discussed in this book open up your mind towards some nice corners of Python language. This book is an outcome of my desire to have something like this when I was beginning to learn Python. If you are a beginner, intermediate, or even an advanced programmer, there is something for you in this book. Please note that this book is not a tutorial and does not teach you Python. The topics are not explained in depth. Instead, only the minimum required information is given. I'm sure you are excited as I am, so let's start. Note, this book is a continuous work in progress. If you find anything which you can further improve, I know you will find a lot of stuff, then kindly submit a pull request. Author, I am Muhammad Yusuf Lola Khalid. I have been programming extensively in Python for over 3 years now. I have been involved in a lot of open source projects. I regularly blog about interesting Python topics over at my blog. In 2014, I also spoke at EuroPython, which was held in Berlin. It is the biggest Python conference in Europe. If you have an interesting internship opportunity for me, then I would definitely like to hear from you. A side note, I have the author's link in the description. Check him out, he's awesome. Thanks everyone. Okay, let's go to the first chapter. Welcome, Alyssa. Welcome, okay, Ari Monica here. You're welcome to learn coding. It's fun and relaxing. I'm reading it on Read the Docs, so I'm doing it on its order. The first chapter is Args and Keyword Args. I have come to see that most new Python programmers have a hard time figuring out the args and keyword args magic variables. So what are they? First of all, let me tell you that it is not necessary to write args or keyword args. Only the asterisk is necessary. You could also have written asterisk var and asterisk vars. Writing asterisk args and asterisk keyword args is just a convention. So let's take a look at asterisk args first. I'll say it as args from now on. Okay, 1.1 Usage of args. Args and keyword args are mostly used in function definitions. Args and keyword args allow you to pass an unspecified number of arguments to a function. So, when writing the function definition, you do not need to know how many arguments will be passed to your function. Args is used to send a non-keyworded variable length argument list to the function. Here is an example to help you get a clear idea. Now I'm going to read a block of code. Bear with me. Define test var args farg variable column print first normal arg farg for arg in arg variable print another arg through arg variable arg test var args sub python x test. This produces the following result. First normal arg sub another arg through arg variable python another arg through arg variable x another arg through arg variable test. As a side note, I am not very familiar with advanced Python, so if I made any mistake pronouncing, please let me know. I'm doing this to learn myself too, so yeah, enjoy. Welcome Eric, welcome World of Music, welcome Lloyd, welcome Limit of X. I hope this cleared away any confusion that you had, so let's talk about keyword args. I think in the code block, like just as I am thinking, it is printing the first normal argument and printing the rest of it. 1.2 Usage of keyword args. Keyword args allow you to pass keyworded variable lengths of arguments to a function. You should use keyword args if you want to handle named arguments in a function. Here is an example to get you going with it. Fine, Lily. Okay, here comes a block of code again. Define greetme keyword arguments for key value in keyword arguments.items print 0 equals to 1 dot format key value. now running greet me with the argument yasub. Greet me with a keyword argument of value name equals to yasub. The output is name equals to yasub. So it's a pair of key and value. I see. So now you can see how we handled a keyworded argument list in our function. This is just the basics of keyword arguments, and you can see how useful it is. Now let's talk about how you can use args and keyword args to call a function with a list or dictionary of arguments. Welcome Crystal Classy, welcome Download Fury, welcome, thank you Brody for bringing people. Thank you so much. So now I look back to the code block. I think the keyword arguments are a pair of key and value, and we are printing the greetMe function prints the keyword arguments. It prints the key equals to value, so the output will be name equals to yasub. I'm also learning. Okay, 1.3. Using args and keyword args to call a function. So here we will see how to call a function using args and keyword args. Just consider that you have this little function. Define test args, keyword args, arg1, arg2, arg3, column, print arg1, arg1, print arg2, arg2, print arg3, arg3. Now you can use args or keyword args to pass arguments to these little functions. Here's how to do it. Another code block. First with args. Args equals to the 2, 3, 5. Test args, keyword args, args. It takes in the args and it prints the 3 arguments in my understanding. So the result will be arg1 is 2, arg2, well, it is arg1 column 2, arg2 column 3, arg3 column 5. And now with keyword args. So here we have a dictionary. First we have we had a list, now we have a dictionary of keyword arguments. The key arg3 has value of 3, key arg2 has value of 2, key arg1 with value of 5. And with test arg keyword arguments, it prints each of the arguments. So arg1, it prints the value 5. Arg2, it prints 2. Oh, it prints the value only. And arg3, it prints the 3. If I made any mistake, please let me know. I'm trying to understand. Order of using args and keyword args and formal args. So if you want to use all 3 of this function, then the order is some function, function args, and keyword args. 1.4. When to use them. It really depends on what your requirements are. The most common use case is when making function decorators, discussed in another chapter. Moreover, it can be used in monkey patching as well. Monkey patching means modifying some code at runtime. Consider that you have a class with a function called getInfo, which calls an API and returns the response data. If you want to test it, we can replace the API call with some test data. For instance, a code block, import some class, define getInfo, self args, return test data. Some class.getInfo equals to getInfo. I'm sure you can think of some other use cases as well. So I think this is replace the API code with some test data, which will be pretty useful in testing, in my understanding. Awesome, so that's the end of Args and keyword Args. Now on to Chapter 2. Debugging. Does people have a question or want to discuss anything? Let me drink some water. Okay, everybody is falling asleep. Perfect. Now we can move to debugging, so you can debug in your dream. Chapter 2, Debugging. Debugging is also something which once mastered can be greatly enhance your bug hunting skills. Most newcomers neglect the importance of Python debugger, PDB. In this section, I am going to tell you only a few important commands. You can learn more about it from the official documentation. Running from the command line. You can run a script from the command line using the Python debugger. Here is an example. The command is python-m pdb myscript.py. It will cause the debugger to stop the execution on the first statement it finds. This is helpful if your script is too short, or this is helpful if your script is short. You can then inspect the variables and continue execution line by line. So this is helping it to find the first statement, and you can run line by line after the first statement is found. So python-m pdb myscript.py will help it to execute line by line, if I think it is correct. Okay, next one. Running from inside a script. You can set breakpoints in the script itself, so you can inspect variables and stuff at particular points. This is possible using the pdb.setTrace method. Here is an example. Code block. Import pdb. Define make bread. pdb.setTrace. Return, I don't have time. Print, make bread. Try running the above script after saving it. You would enter the debugger as soon as you run it. Now it's time to learn some of the commands of debugger. Commands. C is for continue execution, C as Cyan. Continue execution. W as white shows the context of current line it is executing. A as alpha prints the argument list of current function. S as snake execute the current line and stop at the first possible location. N as Yang continue execution until the next line in the current function is reached or it returns. The difference between next and step. Oh, wait, hold on. So N is for next and S is for step. That makes sense. Okay, so the difference between next and step is that step stops inside a code function, while next executes code function at nearly full speed, only stopping at the next line in the current function. Hello Jim, welcome. So those are the commands for PDB. C is for continue. W shows the context of current line. A prints the argument list of current function. S execute the current line and stop at the first possible occasion. And N continue execution until the next line in the current function is reached or it returns. These are just few commands. PDB also supports Postmortem. It is also a really handy function. I would highly suggest you to look at the official documentation and learn more about it. Since it is suggested, let me take a look. What is Postmortem? It seems to be a way to debug. Okay, that will be today's homework to understand what postmortem is. This is even better than I expected. Thank you, Ben. Note: it might seem unintuitive to use pdb.setTrace if you are new to this. Fortunately, if you are using Python 3.7 plus, then you can simply use the breakpoint built-in function. It automatically imports PDB and calls pdb.setTrace. Okay, that's the end of chapter 2. I never knew you can just set breakpoint in Python like that. I always use IntelliJ. This is something new to me, although I have used like stab and next before. Very nice book. Also, I saw some comments for the first chapter. Debugging dreams? It could be a nightmare or the sweetest dream. Monkey patching is also sometimes referred to as metaprogramming, or basically code that generates or modifies code at runtime. Oh, that was what was talking about, the modifying code at runtime. Warrior-san is gonna take a quick nap. That's me. Postmortem autopsy. Hello Vanilla, welcome. Ah, so when we debug, it's almost like autopsy. That's really true. We look at every single corner we can look at. Yellow, yep, welcome, hello, welcome back. Python should include clips of this stream like audiobook version of the docs. I'll be so embarrassed. The author of the book deserves so much more credit. So yeah, shout out to him. Muhammad, good job. Okay, we have gone through arguments, keyword arguments, and debugging. Let's look at the fun generators. Ohayo, ohayo. Oh yeah, Yoru, welcome again. Good morning, 大家好，安安。Okay, chapter 3, generators. First, let's understand iterators. According to Wikipedia, an iterator is an object that enables a programmer to traverse a container, particularly lists. However, an iterator performs traversal and gives access to data elements in a container, but it does not perform iteration. You might be confused, so let's take a bit slow. There are 3 parts, namely, the first is iterable, second is iterator, and the third is iteration. All of these parts are linked to each other. We will discuss them one by one and later talk about generators. 3.1 Iterable. An iterable is any object in Python which has an iter or getItem method defined which returns an iterator or can take indexes. You can read more about them here. An iterator is any object in Python which has an iter or getItem method defined which returns an iterator or can take indexes. An iterable. Let me read a little bit. So the link goes to a Stack Overflow question. What's the difference between iter and getItem? The getItem version is a legacy before Python had modern iterators. The idea was that any sequence, something that is indexable and has a length, would be automatically iterable using the series S0, S1, S2 until index 0 or stop iteration is raised. In Python 2.7, for example, strings are iterable because of the getItem method. The string type does not have an iter method. So the string type does not have iter method, but it has getItem. In contrast, the iterator protocol lets any class be iterable without necessarily being indexable. Dicts and sets, for example. So there are no index in dicts and sets, but they are iterable. Here is how to make an iterable class using the legacy style for sequences. Which a bunch of code? Should I read it? They're pretty long. And there's another code to make an iterable using the iter approach. So you can make iterables yourself by implementing getItem and iter. Am I correct? I don't know. Let me send you the link in the chat. Side note, method starting and ending with double underscore is called Thunder method. It's core part of Python's protocol. Ah, it's Thunder's method. I see it all the time, but I don't know how to call them. Is there a specific way to say them? Do I say like underscore? Thunder method are names that are preceded and succeeded by double underscores, hence the name Thunder. They are also called magic methods and can help override functionalities or built-in functions for custom classes. Thank you, Jupiter. That's an interesting read. Nice. So, go back to our iterable. In short, an iterable is any object which can provide us with an iterator. So, what is an iterator? (3.2) Iterator. An iterator is any object in Python which has a next or next method defined. That's it. That's an iterator. The iterator has a next method. That's the definition of it. Now, let's understand iteration. 3.3 Iteration. In simple words, it is the process of taking an item from something, for example a list. When we use a loop to loop over something, it is called iteration. It is the name given to the process itself. Now, as we have a basic understanding of these terms, let's understand generators. 3.4 Generators. Generators are iterators, but you can only iterate over them once. It's because they do not store all the values in memory. They generate the values on the fly. You can use them by iterating over them either with a for loop or by passing them to any function or construct that iterates. You can use them by iterating over them either with a for loop or bypassing them to any function or construct that iterates. So you can use for loop, you can pass them to any function or construct that iterates. Most of the time, generators are implemented as functions. However, they do not return a value. They yield it. Here is a simple example of a generator function. A code block. Define generator function column. For I in range 10, yield I. For item in generator function column, print item. So the output will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It prints from 0 to 9. And we're iterating through the generator by using for item in the generator. It is not really useful in this case. Generators are best for calculating large sets of results, particularly calculation involving loops themselves. Generators are best for calculating large sets of results where you don't want to allocate the memory for all the results at the same time. Many standard library functions that returns lists in Python 2 have been modified to return generators in Python 3 because generators require fewer resources. Here is an example generator which calculates Fibonacci numbers. Code block, generator version. Define Fibon n, column a equals to b equals to 1. For I in range n, column yield a comma b equals to b comma a plus b. On a side note, I remember there are so many different ways to do Fibonacci numbers, so it's a great question to look at. Yes. So yeah, we're currently using generator to calculate Fibonacci numbers. We first set a and b equals to 0, and for I in range n, we yield a, and we set a equals to b and b equals to a plus b. Now we can use it like this. A code block. For x in Fibon, a million, print x. This way we won't have to worry about it using a lot of resources. However, if we would have implemented like this, in its normal way using a list, code block, define Fibon n. A equals to b equals to 1. Result equals to an empty list. For I in range n, column result dot append a comma b equals to b comma a plus b, return result. You will have used up all our resources while calculating a large input. We have discussed that we can iterate over generators only once, but we haven't tested it. Before testing, you need to know about one more built-in function in Python. Next. It allows us to access the next element of a sequence, so let's test out our understanding. 卫士早上好 Come you back! Good morning! Yeah, so now we will be using the next function in our code block. Define generator function column for I in range 3 column yield I. Generator equals to generator function, print next gen, and output will be 0. And we print the next of the generator is gonna give us 1. And then we print next gen, it's gonna give me 2. Print next gen, it's going to give me an arrow because range 3 is just 0, 1, 2. So you output a traceback of the arrow detail. Stop iteration. As we can see that after yielding all the values, next caused a stop iteration arrow. Basically, this is an arrow to inform us that all the values have been yielded. You might be wondering why we don't get this arrow when using a for loop. Well, the answer is simple. The for loop automatically catches this arrow and stops calling next. Did you know that a few built-in data types in Python also stop iteration? Let's check it out. A code block. My string equals to Yasub. Next my string. And this is going to output an arrow. Type arrow string object is not an iterator. Well, that's not what we expected. The arrow says string is not an iterator. Well, it's right. It is an iterable, but not an iterator. This means that it supports iteration, but we can't iterate over it directly. So how should we iterate over it? It's time to learn about one more built-in function, iter. It returns an iterator object from an iterable. When an int isn't an iterable, we can use it on a string. While an int isn't an let me try again. While an int isn't an iterable, we can use it on a string. So we are trying to make a iterable out of a string. Is it? Wait, hold on. Python use exceptions as control flow. So string is not an iterator. It's an iterable but not an iterator. And we iterate over it by using a built-in function iter. Another code block, int variable equals to... Oh! My cat rubs the microphone, sorry. It was loud. Oh, stop. I'm doing ASMR. Stop. Okay, he's gone. Sorry about that. Okay, he's not gone. I hold him, so be careful. Okay, the code block. Int variable equals to 1779. Iter int variable is going to give us an arrow, because int object is not iterable. But if we have a variable named myString and its value is yasub, and an iter of name myiter equals to iter myString, and we print next of myiter, it's going to print the first letter of the string, which is y. So we made an iter out of myString. We made an iterable object from the string, so we can iterate the string. Still comfy, thank you. I hope the cat is nice to y'all. Okay, now that is much better. I'm sure that you loved learning about generators. Do bear it in mind that you can fully grasp this concept only when you use it. Make sure that you follow this pattern and use generators whenever they make sense to you. You won't be disappointed. And that's the end of chapter 3. Are there any questions, my eager young pupils? Welcome, Foxy Hen House. Thank you, Limit of X. I'm glad you get to sleep, Warrior-san. Feel free to sleep with it. You're going to be smarter after stream ends. This is like how mummies put musics on their tummy when they have babies. I am Mama at work. Welcome, Yokha. This is not ASMR, this is Python reading. Because if I say it's ASMR, I might get banned, so I'm just reading a book. Thank you, Ice Cat. Thank you, Ice Cat. Does Onion Star Cats are so cute? That's a good question. Ask the Neon Star Cats. Okay, no questions. We can go to chapter 4, right? Map, filter, and reduce, our favorite data science tools. Data science. This is the most relaxing thing I've listened to this month. Thank you, Adam. The music is really relaxing. Okay, chapter 4. Map, filter, and reduce. There are 3 functions which facilitate a functional approach to programming. We will discuss them one by one and understand their use cases. 4.1 Map. Map applies a function to all the items in an input list. Here is the blueprint. Map. First argument is function to apply. Second argument is list of inputs. Are you kidding me? There was no music? Do you hear music now? I'm gonna cry. I have a really good music. Holy moly. I am so sad. There was no music at all. How about now? Do we have music now? Oh my god. I have been listening to this since the beginning of the stream. Okay, I'm going to hide in a box after the stream, but let's continue. I'll find a good box to hide. Thank you for letting me know there hasn't been music since the beginning of the stream. I will cry quietly in the inside. Yes. Alright. Chapter 4. Map, filter, and reduce. These are 3 functions which facilitate a functional approach to programming. We all discuss them one by one and understand their use cases. 4.1 Map. Map applies a function to all the items in an input list. Here's the blueprint. Map. Function to apply, list of inputs. Most of the times we want to pass all the list elements to a function one by one and then collect the output. For instance, code block. Items 1, 2, 3, 4, 5 in a list. Squared, an empty list. For I in items, squared.append I times 2. So this is appending each of the item into the squared list, and for each item it calculates the square. Map allows us to implement this in a much simpler and nicer way. Here you go. Code block. Items equals to 1, 2, 3, 4, 5 in a list, and squared equals to list of map of lambda x column x times 2 comma items. So it's a lambda function, which is a way to define function easily in Python, and you calculate the square by exponential, which are 2 asterisk, and you use map to apply this function to items or each element in items, and you convert it to a list. Most of the times we use lambdas with map, so I did the same. Instead of a list of inputs, we can even have a list of functions. Code block. Define multiply x. Column. Return x times x. Define add x. Column. Return x plus x. Funcs equals to a list of multiply and add. So it puts the two functions into a list. And for I in range 5 column, value equals to a list of map lambda x column xi funcs. Print value. Let's guess the result of this. So the outputs are 0, 0, 1, 2, 4, 4, 9, 6, and 16 and 8. The functions are multiply and add. So when I equals to 0, what will happen? Oh. Hold on, I'm not understanding it. Let me test it in my code. In a Python. Let me run Python online. Did you guys know there are free shell you can use? So many of them. You can test the code on a browser. What a peaceful moment. Thank you, Yume-chan. Ah, okay, now it makes sense. So first it calculates the square of that number, and then it calculates the 2 times of the number. Okay, now it makes sense. It doesn't have explanation, but it takes the number I, and I is ranging from 0 to 4, and then for each list, the first number is the square, and the second number is 2 times the number. So 0, 0. So for 0 is 0, 0. For 1 it's 1 times 1 and 1 plus 1. For 2 it's 2 times 2 and 2 plus 2. And for 3 is 3 times 3 and 3 plus 3. And for 4 it's 4 times 4 and 4 plus 4. Okay, now I understand lambda and map better. Welcome next. Okay, that was map. Are there any questions? The next one is pretty similar. It is called filter. As the name suggests, filter creates a list of elements for which a function returns true. Here is a short and concise example. Code block. Number list equals to range -5, 5. Less than 0 equals to list of filter of lambda x column x less than 0 number list. So the lambda function is used as a filter to filter the number list, and only put numbers that are less than 0 into a list, and that list is getting print. So for range -5 to 5. What does it start with? I think it starts with -5 and goes up to 4. So it puts -5, -4, -3, -2, and -1. They qualify the condition of the filter, and they are printed. Awesome, that was filter. The filter resembles a for loop, but it's built-in function and faster. So if you wanna be faster, use filter. Note, if map and filter do not appear beautiful to you, then you can read about list dict tuple comprehensions. This comprehension is cool. I use it a lot. Awesome, next one is reduce. It makes me think of MapReduce. I read a paper about it. But I don't remember a lot. It is sort of similar to this. Maybe it is this. It saves the calculation time a lot, and that's why data science has been improved so much, because we got better algorithms and hardware. My very basic understanding of data science. Okay, reduce. Reduce is a really useful function for performing some computation in a list and returning the result. It applies a rolling computation to sequential pairs of values in a list. For example, if you wanted to compute the product of a list of integers. So the normal way you might go about doing this task in Python is using a basic for loop to compute the product of a list of integers. So product equals to 1, list equals to a list of 1, 2, 3, 4, and for each number in the list, the product is equals to product times num. And you use 1 times 1, 2, 3, 4, and it gives you 24. Hola loca simias, welcome. So yeah, that's a basic way to do a product without reduce. Now let's try it with reduce. A code block. From functools import reduce. Product equals to reduce lambda x y column x times y. And then the second argument is a list of 1, 2, 3, 4. And it reduces the list. So for every element, it multiplies the next element. So 1 times 2 times 3 and times 4, it gives us 24. That's awesome. I remember this reduce the dimension. So a 1D array is becoming a 1 number. So yeah, that's the power of reduce. And that's the end of chapter 4, map, filter, and reduce. Are there any questions or suggestions? Stay hydrated. Map, filter, and reduce. Yeah, if you guys don't know, Python is one of the most famous language for data science. It's not the quickest language. You know, C++ and Rust, I think they are a lot faster, but it has powerful library like Keras, like TensorFlow, that makes it so useful and versatile. Python can also do website, it can do scripting, it can do basically everything in a high level. So yeah, it's also a great language to learn for beginners. Some other data science languages, or it's like for big data, I think there's Spark, there's Hadoop, and it uses like MapReduce a lot. If you are interested in machine learning, I think it is very tightly coupled, very close to data science. Because machine learning algorithms, they use data, a lot of data to train their models. So yeah, if you are interested in that, take Python and learn probabilities. Happy doing math. Alright, next chapter. Chapter 5. Set data structure. Set is a really useful data structure. Sets behave mostly like lists, with distinction that cannot contain duplicate values. It is really useful in a lot of cases. For instance, you might want to check whether there are duplicates in a list or not. You have two options. The first one involves using a for loop, something like this. Code block. Some list of ABCDEF. Oh wait, ABCBDMNN. That's a list with duplicated B and N. And there's a list of we initialize a list of duplicates, an empty list that's named as duplicates, and for each value in our letter list, SUMList, if SUMList count value is larger than 1, so if any value in the list appears more than one time, and if the value is not in the duplicates, then we append that value in the duplicates, and then we can eventually print the duplicates to be B and N. Counting, I think, is a pretty expensive calculation, so yeah, that was pretty expensive. But there is a simple and more elegant solution involving sets. You can simply do something like this. Code block. SUMList equals to ABCBDMNN, the letter list we just had. And duplicates equals to, we use the set function, so set of a list, and in the list we have list comprehension, x for x in SUMList if SUMList.count x is larger than 1. Okay, we still have the count, I see. But set makes finding the duplicates much easier, I think. Let me see, what exactly does it do? So it iterates the list, the letter list, and find the letter that occurs more than one time, and it put it into a set. So there like no 2B or 2N in the duplicates. They're all unique letters. Sets also have a few other methods. Below are some of them. Intersection. You can intersect two sets. For instance, code block valid equals to set of a list of yellow, red, blue, green, black. The next line, input set equals to a set of a list of red and brown. And you print the input set dot intersection valid. So I see set has a built-in function called intersection, and in math it is the common elements you have in two lists. So if you use set A dot intersection set B, it's going to return all the common element in a set. So yeah, it returns a set of a list red because the both input set have the word red. Difference. You can find the valid values in the above example using difference method. For example, code block valid equals to a set of list yellow, red, blue, green, black. Input set equals to a set of list red, brown. Print input set dot difference valid. And you can see brown. So I think it is comparing the difference between input set and valid contains all the valid cover, and in the input set we have red, and red is also in the valid set, but in the input set we also have brown, but brown is not in the valid set. So yeah, the difference calculates the difference. So brown is not in the valid set, and that's our difference. Welcome group Ina. Welcome again, thank you. You can also create sets using the new notation. Code block A set equals to red, blue, green. That's much easier. You don't need to use the set function to do a set. You just do curly braces. And then you print a type. You print the type of a set, and that is a set. So yeah, you don't need to use the set function to initialize a set. You can directly initialize it with curly braces. There are a few other methods as well. I would recommend visiting the official documentation and giving it a quick read. Awesome, that was set. Any question? I remember using this for threesome in LeetCode. Really handy in checking duplicates. Oh, yes, the A equals to curly braces, empty curly braces defaults to dictionary. But if it has elements without the key and value pairs, it is set. But if you have key and value pairs in curly braces, then it's dictionary. Awesome. I always find Python fascinating because the syntax is pretty short. So yeah, I use it for coding interview because it's a language that helps communicating ideas. It's easy to read. Sometimes it's almost like writing English. So yeah. Thank you, FC. Okay, ready for chapter 6? We got ternary operators. Ternary operators are more commonly known as conditional expressions in Python. Conditional expressions. These operators evaluate something based on a condition being true or not. They became part of Python in version 2.4. Ratamoche, welcome. Thank you for the good luck. Yes. Thank you for dropping by. Set is mostly used like this: set A and set B, set A plus set B, set A minus set B, etc. using methods are or this. Ah, really? Oh wow, with the plus, minus, and it's much easier. So minus is difference, and plus is like union. Oh, yeah. What was it? You will learn this in discrete math or in your Asian high school education or in AP statistics. Very useful. Awesome. Thank you, Jovita. I should learn Python one day. Well, you're learning it right now. Welcome by DM. Alright, ternary operators. Let's look at the blueprint. Blueprint and an example of using these conditional expressions. A blueprint. Value if true, if condition, else, value if false. This is really handy. It makes like you don't need to have multiple lines for a condition. Side note, but I don't know if it's the best practice. I mean, if your code is readable for other people, then it is good. Depending on your purpose though, if teamwork is good to have readable, maintainable, easy to understand code. So, an example from the blueprint. We have a boolean of is nice and it equals to true. And we have a variable state equals to nice. The string nice if it's nice, else not nice. Okay, so basically you have a condition, and if the condition qualifies, we will return the first result, and if it doesn't qualify, we return the else case.冰喵还要做贪婪，不着急啦，没关系，小人可以自己做。但自己说的话，自己会记得比较清楚。冰喵好好休息，不要忙太多啦。Yes, that is ternary operators. Super easy, right? It allows to quickly test a condition instead of multi-line if statement. Oftentimes, it can be immensely helpful and can make your code compact but still maintainable. Another more obscure and not widely used example involves tuples. Here is some sample code. Blueprint. Code block. If test is false, comma, if test is true. Those are in a tuple. And square bracket test. Example. Code block. Nice equals to true. Personality equals to tuple of mean and nice, and a square bracket of nice. Print the cat is, comma, personality. Output the cat is nice. I feel this is much easier to write compared to the first one, but I don't know like if other people know about how to write a ternary operator using a tuple and a boolean. So basically, you put the true and false condition in a tuple of two elements, and you put a like an index, but it is instead of index, it's like a boolean to indicate you want the true condition or the false condition. And this works simply because true equals to 1 and false equals to 0. 0 is the first element and 1 is the second element, so it works perfectly with a tuple of 2. And so it can be done with lists in addition to tuples. That is so smart! The above example is not widely used and is generally disliked by Pythonistas for not being Pythonic. It is also easy to confuse where to put the true value and where to put the false value in a tuple. Another reason to avoid using a tuple ternary is that it results in both elements of the tuple being evaluated, whereas an if-else ternary operator does not. Okay. So maybe this is not a best practice, because it will get the negative condition evaluated by the if-else statement. If the else statement is not qualified, it won't be evaluated, and same as the if statement. Interesting. Example: code block. A boolean of condition equals to true. Print 2 if condition, else 1 divided by 0. Output is 2. Print 1 divided by 0, 2. Condition. And you will return 0 division error because Python can handle denominator. It be 0. This happens because with the tuple ternary technique, the tuple is first built, then an index is found. For the if-else ternary operator, it follows the normal if-else logic tree. But if one case could raise an exception based on the condition, or if either case is a computation-heavy method, using tuples is best avoided. Hold on. So, when condition equals to true, okay, that's interesting. So in this example, I didn't get it at the first place, but now looking at it, when you print a tuple of 1 divided by 0 and 2, and with condition equals to true, and so condition is evaluated to be 1, and it is supposed, like, you would imagine it to print 2, but because it evaluates 1 divided by 0, it will throw you an error instead of giving you the 2 that you wanted. So that's why you should avoid tuple condition if it's computation heavy or throws exception. Next, shorthand ternary. In Python, there's also a shorthand ternary tag, which is a shorter version of the normal ternary operator you have seen above. Syntax was introduced in Python 2.5, and it can be used in Python 2.5 or greater. As a side note, I think Python 2 has, at this point, has officially been outdated. So if you learn Python, start with Python 3. Example: code block. True or sum, it will print truth. It will print true. False or sum, it will print sum. The first statement, true or sum, will return true, and the second statement, false or sum, will return sum. This is helpful in case where you quickly want to check for the output of a function and give a useful message if the output is empty. It's good for error checking, so let's see in this example. A code block. So we set output to equals to none and message to equals to output or no data returned. and we print the message. And since there is the output is none, it goes to the right hand side of the OR, and it prints the error message of no data returned. So yeah, this shorthand ternary is a good way to check for existence and print error message. Or as a simple way to define function parameters with dynamic default values. So another code block. Define my function parameters has real name put optional display name equals to none. Optional display name equals to optional display name or real name. Print optional display name. And you put June as the argument, so my function June. And since we are given the real name, it's gonna print the real name, which is June. June. And wait, hold on. So the real name is required, but optional display name is not required. Sorry, I probably said it wrong. So we gave it the real name, and the optional display name is none. So you first look at the optional display name and it's none, so it goes to show the real name. And now in the second parameter, in the second function, second statement, my function Mike anonymous 1 to 3. We gave the optional display name, so in the shorthand ternary, it's going to evaluate the optional display name and ignore the real name, so it's gonna print anonymous 1 to 3 instead of Mac. Right. Welcome Ayashinaki, hello. Welcome Maxwell Fang. Among Us. Among Us, you wanna play? It's a good game. Alright, that's the end of the Ternary Operators. I learned a lot. What about you guys? Any questions? So yeah, we learned we can use the longer case to do the if else in one line, or we can use the tuple way of doing ternary operator, but be careful of heavy computation or exceptions in the tuple. And we also look at how we can use it to, we can use the shorthand ternary with the OR to some error message or do some logic. 到第7章节了吗？要到啦。Among Us? Among Us? What is Among Us, guys? What is it about? Is the background music sound like the BGM? To be honest, I didn't even know tuple ternary existed. Me neither. That's a pretty cool way, like the logic of it. Maybe someone invented it. It's not. I don't know if this is intentionally designed. I don't know. We can look into like what's the story behind it. How much longer do you guys wanna go for it? So in total we have 27 chapters. So maybe I can do this stream for 3 times, and I'll stop at chapter 9. So I'll go over chapter 7 Decorators, chapter 8 Global and Return, and chapter 9 Mutation. What do you guys think? I wasn't aware either. You always learn something new. I feel like today 40 to 60% of the content are new to me, even though I have been using Python for a while. Sometimes I learn stuff from like Stack Overflow, but today is like the first time I actually look at the docs, read the book, read this amazing book to know like how it actually works, and it really explains it pretty well. Okay, since we have 3 more chapters to go, let me take 2-minute break. Let me get some more water, and I'll see you back See you guys back in 2 minutes. If you have questions, discussions, leave it in the chat. I'll be back in 2 minutes. Bye. Hello, I'm back. How's audio? Any questions? Any interesting findings and suggestions? That proves nobody reads the documentation. Well, we are reading it. I have been using Python for a few years now, and I'm learning new things today too. Awesome! I hope those of you who are working are not disturbed. Relaxing and educational. Thank you. I hope this works like when mommies put educational music, classic music on their tummy to educate the babies. One day I'll look at my stream and listen to it myself. Hopefully. And be ashamed. What? Jupiter said I'm so inexperienced with Python? I look up to you, Jupiter. And any particular direction I should be focusing on? I mean, you're so strong at it. You can use it to do a lot of do a lot of stuff. I already know. It depends on your interest in computer science. There's so many areas in computer science. Like, if you go to the design side, there's like human-computer interaction, front-end, UX, UI design, right? I don't know how much of Python is involved in that. It's more like TypeScript, React, design world. Other things, Python can write applications like Django. Flask is like lightweight, but you can definitely use it to write your website. Backend, you can do. Not so sure about games. I know Renpai can do the cute anime games. I'm sure there are many tiny games you can write with Python. What else? What else? What have I done in Python? I mostly use it to learn algorithms. And as I said, the data science, if you are interested in data science, machine learning, AI, Python is gonna be so much help. And the world of NumPy is like another world. With all the 3D, even like n-dimensional vectors, other vectors. That's gonna be really interesting. So yeah, discover what you like. And don't be limited by language. If you master one language, I'm sure you can learn another language with like really quick speed because they're sort of related. Like the basics are the same. So yeah, depending on what you're interested in. And yeah, be flexible on language and tools because you will learn plenty in your journey to be a dev, I think. Welcome, Yu-chan. Hello. More like what would get me hired with Python. I think with your skill, you can already do that. Maybe like get hired specifically, practice with LeetCode or whatever job technical question you get in your interview in your country. If you look at money, which I don't recommend, I mean programmers generally are paid well, although they lose their hair and spend so much time on work. It's stressing. It's a relatively stressing job. It's easy to find a job if you know programming, I would say, like compared to other jobs. It also depends. Sometimes layoff happens. It does happen, so it's good to have extra skill. Yeah. Right now, data science is pretty hot and it gets you paid well, but it's a lot of math, so it depends on what you like. Hey, that's my answer. I don't know if it's helpful. I'm like inexperienced, so yeah, ask around. Ask around. Talk Life, welcome. Hello, Chasapalu. Oh, Chasapalu, thank you. Welcome. I did some basic neural net stuff in a class a year ago with TensorFlow and NumPy, and it was such a totally different world from what I was used to. It is very different. TensorFlow and NumPy. If you dig into like the design, like inside of a neural network, how each layer are connected, you get to calculate all the 512, like how many neurons are there. I hate math personally. I can do it in a higher level, like I can tune the parameters. It gets a little boring to me, but I'm saying it in a very subjective way. But people are interested in it. People who are data scientists are developing better models, and it's a very rapidly growing field, and it can be applied in a lot of stuff. So, すごい Cool. Enough money to pay Cyan tax will be enough for me. Why do you need to pay me and to pay you? Thank you. Thank you, Jivita. Thank you, Ice Cat. Alright, I get my water. We can start with our exciting decorators. Are we ready? Okay, Chapter 7, Decorators. Decorators are a significant part of Python. In simple words, they are functions which modify the functionality of other functions. They help to make our code shorter and more Pythonic. Most beginners do not know where to use them, so I'm going to share some areas where decorators can make your code more concise. First, let's discuss how to write your own decorator. It is perhaps one of the most difficult concepts to grasp. We will take it one step at a time so that you can fully understand it. I'm so excited. I'm so excited to learn decorators because I never get to learn it. So let's go. 7.1 Everything in Python is an object. First of all, let's understand functions in Python. Define hi. Function hi. And the argument is name equals to yasup. Column return hi plus name. Print hi. Output hi yasup. We can even assign a function to a variable like greet equals to hi. So we assign the function hi to the variable greet. We are not using parentheses here because we are not calling the function hi. Instead, we are just putting it into the greet variable. Let's try to run this. Print greet. Output hi yasup. Let's see what happens if we delete the old hi function. Del hi, print hi, outputs name arrow. Oh, the old function is gone. And then we print greet, and then it prints hi yasup. So I think I'm not very familiar with objects in Python, but it says everything in Python is an object. So the function hi is an object as well. And by using the parentheses we are calling the functions, we can assign a function to a variable, and after the assignment, the greet function does exactly the same as the function hi, and even if hi is deleted, greet still does what hi does. I think this is what it is. Welcome, Lucas. Welcome, Xenobite of Sec. I stream Trihack Me Labs and the pen testing. That's so cool. Wow. Nice. Melu Senpai, welcome. Thank you, Yu-chan. Thank you, Eric. Thank you, Ark. Yes, that was everything in Python is an object, and that's how you store function into a variable. Easy concept of Python name variable is posted stuck on for object in memory. So the variable easy concept of Python name variable is posted stuck on object in memory. I'll catch with you on what that means. Posted is the sticky things, the sticky pad? Is it? Okay, chapter 7.2, defining functions within functions. So those are basics when it comes to functions. Let's take your knowledge one step further. In Python, we can define functions inside other functions. Like code block. Define hi, name equals to Yasup. Print, now you are inside the hi function. Define greet. Return, now you are inside the greet function. Define welcome. Return, now you are inside the welcome function. Print greet. Print welcome. Print, now you are back in the hi function. So yeah, in Python you can define function inside function. And then you call hi. There are many outputs. So the first one is now you are inside the hi function. And the second is now you are inside the greet function. And third is now you are inside the welcome function. And fourth, hold on. It prints the function inside IC, and eventually it goes back to the hi function. Yes, so in the hi function, it has two functions defined as greet and welcome, and in the hi function, it prints the two functions defined inside the hi, and yeah, it gets caught when hi is called. This shows that whenever you call hi, greet, and welcome are also called. However, the greet and welcome functions are not available outside the hi functions. For example, if we call greet function outside, so we call greet function outside, or call it outside the hi function, then it won't work because the definition is within the hi function. So calling it outside will return a name error saying name greet is not defined. So now we know we can define functions in other functions. In other words, we can make nested functions. Now you need to learn one more thing, that functions can return functions too. Okay, going back to Jupyter's comment, a equals to 10 means POSIT written a is stuck on object 10. So going back to 7.1, I don't know if I have said it right or not, maybe I said it wrong. So if we apply it to our example, it means that when we define hi, we have a function object, but with a POSIT of hi as the function name. And then when we do greet equals to hi, we simply put the POSIT of greet on this. Is it on the same object as hi, or we copied it? So we put it on the same object. We basically have two names for one function object. Correct me if I'm wrong, I'm not sure. And then when we delete hi, it took off the POSIT, the sticky notes. and on the function object, there's only one sticky note that is greet. Is that what it is? Hello, Pandy Toast, welcome! Thank you, Jupiter, that's a really great analogy. I remember it. Yo, I finally understand why they say everything in Python is objects. Thank you, Jupiter. Nice! Awesome. Okay, we go back to chapter 7.3, returning functions within functions. Did we finish it? We didn't. Okay, let's start it. It is not necessary to execute a function within another function. We can return it as an output as well. So, a code block. Define hi. Name equals to Yasub. And inside the hi function we have define greet. And it returns now you are in the greet function. And then define welcome, return now you are in the welcome function. And if name equals to Yasub, we return greet. Else we return welcome. So here functions are directly returned from a mama function. So now we set an a variable a equals to hi and we print a. And it outputs function greet at 0x7f2143c01500. I think that's the memory address, I guess. And this clearly shows that a now points to the greet function in hi. Because hi did not take any arguments, and if there is no argument given, it goes to hold on. Oh wait, hold on. Sorry, I was wrong. The default argument is name equals to Yasub, and if you don't pass any arguments to the hi function, then it assumes the name equals to Yasub, so it returns, it goes to the if case and return the greet function. Sorry, I got confused. So yeah, this clearly shows that a now points to the greet function in hi because it takes the default parameter and goes to the if case because name equals to Yasub. And now if you do print a, output, now you are in the greet function. Alright, it all makes sense now. Just take a look at the code again. In the if-else clause, we are returning greet and welcome. Not greet method call and welcome method call. Why is that? It's because when you put a pair of parentheses after it, the function gets executed, whereas if you don't put parentheses after that, then it can be passed around and can be assigned to other variables without executing it. Did you get it? Let me explain it in a little bit more detail. When we write a equals to hi parentheses gets executed, and because the name is Yasub by default, the function greet is returned. If we change the statement to a equals to hi parentheses name equals to Ellie, then the welcome function will be returned. We can also do print hi parentheses, which outputs now you are in the greet function. Yeah, so if the name equals to Ellie, which is not Yasub, the welcome function will be returned. And also when a equals to hi parentheses and you do another parenthesis, it's going to be a method call of greet. Yeah, awesome. 7.4. Giving a function as an argument to another function. Code block. Define hi. Column. Return hi Yasub. Define do something before hi function. Print I am doing some boring work before executing hi. Print fuck. Do something before hi. What is it going to print? So it first I'm going to do some boring work before executing hi, and you print the input function, the function that was passing as a parameter, and the function that's put in as a parameter is hi, and it prints hi as soon because it executed. So yeah, we are giving a function as an argument to another function. We're giving hi to do something before hi. Oh my god, my cat. So it can be executed inside do something before hi. Okay, now you have all the required knowledge to learn what decorators really are. Decorators let you execute code before and after a function. Nice channel, thank you, and don't bite off sec. 7.5 Writing your first decorator. In the last example, we actually made a decorator. Let's modify the previous decorator. And my cat is covering the screen. And make a little bit more usable program. No, don't touch it. I'm going to mute a little bit. My cat is going to destroy it. Okay, my cat didn't kill me. Okay, 7.5 Writing your first decorator. In this example, we actually made a decorator. Let's modify the previous decorator and make a little bit more usable program. Code block. Define a new decorator. Input afunc. Column. Define wrap the function. Print. I am doing some boring work before executing afunc. Afunc. Print. I am doing some boring work after executing afunc. Return. Wrap the function. That's the first function, the end of the a new decorator. Define. A function requiring decoration. Print. I am the function which needs some decoration to remove my full smile. Remove my full smile. Okay. So, when I call a function requiring decoration, it outputs I am the function which needs some decoration to remove my full smell. And a function requiring decoration equals to a new decorator, a function requiring decoration. Now a function requiring decoration is wrapped by wrap the function. A function requiring decoration. It's getting wrapped. Okay, I see it now. It outputs I'm doing some boring work before executing afunc. I'm doing the function. I am the function which needs some decoration to remove my full smell. I am doing some boring work after executing afunc. Did you get it? We just applied the previously learned principles. This is exactly what decorators do in Python. They wrap a function and modifies behavior in one way or another. Now you might be wondering why we did not use the add anywhere in our code. It is just a short way of making up a decorated function. Here is how we could have run the previous code using add. Now I think I'm getting it. So a decorator takes a function and do something before and or after it. As simple as that. And add is just a shorthand for decorator. Welcome Mario, welcome Milaku. 欢迎。Okay, code block of showing off what add is in Python. Add a new decorator. Define a function requiring decoration. Column. and with a a comment or what string? I forgot how do you call it, the comment string. Hey, you decorate me, and print. I am the function which needs some decoration to remove my full smell. So you put add a new decorator before the function that require decoration, and then you just call a function requiring decoration, and boom, you will have the decoration. That was so easy. Why did I struggle with decorators? I guess I was just scared by the concept. Cool. Yeah, so with the add a new decorator, now the function that requires decoration prints the decoration. I am doing some boring work before executing a func. I am the function which needs some decoration to remove my full smell. I am doing some boring work after executing a func. The add a new decorator is just a short way of saying a function requiring decoration equals to a new decorator with an input of a function requiring decoration. I hope you have a basic understanding of how decorators work in Python. Now there is one problem with our code. If we run print, a function requiring decoration that... what was it? Draw? The underscore name. The output will be a wrapped function. This is not what we expected. Its name is a function requiring decoration. Well, our function was replaced by wrapped function. So wrapped function was from the decorator. It overrides the name and the docstring of our function. Oh, that thing is called docstring. The comment with like 3 quotes. Docstring. Luckily, Python provides us a simple function to solve this problem, and it is funcfoods.wraps. Let's modify our previous example to use funcfoods.wraps. So yeah, the problem with our previous approach it's because what will happen is it's going to override our function name and docstring, and by using functools.wraps, I think it's gonna solve the problem. So let's take a look. Code block from functools import wraps. Define a new decorator, a func, column, add wraps, a func. Define wrap the function, column, print. I am doing some boring work before executing a func. A func, print. I am doing some boring work after executing a func. Return wrap the function. Add a new decorator. Define a new function requiring decoration, column. Hey yo, decorate me. Print. I am the function which needs some decoration to remove my full smell. Print a function requiring decoration that name. Output a function requiring decoration. So yeah, the functools.wraps solves the problem of the name get changed in the main function. So how does it work? I'm taking a closer look at it. Define a new decorator. Takes a func, and inside the decorator he wraps a func, and he defines how the decorator will behave. And outside of the function that requires decoration, it uses the add the decorator function to say, hey, decorate me. Okay, so you use wraps inside a new decorator, and you add the name of the decorator function outside of the function that requires decoration. Nice. Now that is much better. Let's move on and learn some use cases of decorators. Blueprint. From FunkUtils import wraps. Define decorator underscore name f. So I think this is a decorator. Add wraps f. Define decorated args keyword arguments column. If not can run column. Return function will not run. And outside if return f args keyword args. Return decorated. That was the decorator. And in our main function, it is going to be decorated by the decorator. Add decorator name, define func. Return function is running. And here we define a variable of boolean of name can run. Can run equals to true. And we print the func. We print the func, and it's going to say function is running. And if the can run equals to false, you will say function will not run. Why is that? Let's see together. So can run equals to false, and we print the func, and the func is being decorated by the decorator name. And it has a logic if not can run, which is true in this case because can run is false, so it goes to return function will not run. So yeah, so you will say function will not run. Note: Iterators takes a function to be decorated and adds the functionality of copying over the function name. Docstring, arguments list, etc. This allows us to access the pre-decorated function's properties in Decorator. Awesome, so at wraps, it reserves the function name docstring argument list of the pre-decorated function, so it doesn't get lost in a regular way. Awesome. Mm. 7.5.1 Use Cases. Now let's take a look at the areas where decorators really shine and their usage makes something really easy to manage. 7.5.2 Authorization. Decorators can help to check whether someone is authorized to use an endpoint in a web application. They are extensively used in Flask Web Framework and Django. Here is an example to employ decorator-based authentication. Example: code block. From functools import wraps. Define require auth. Takes function f. Add wraps f. Define decorated arguments keyword arguments. Auth equals to request.authorization. If not auth or not check auth, auth username auth password, authenticate. Return f args keyword args. Return decorated. I think I'm not 100% sure, but I think this is a function a decorator can be used to check for authentication. And request.authorization. So if it is not authorized yet, or if it's not authorized yet, or not check alls, also named as password, or the check alls is false, then you will authenticate. I'm hoping I'm not missing anything, so if somebody finds a problem, just say it in the comment or in the chat. So that's how it does. Authorization. You can use Decorator for authorization. And another place to use it is in logging. Logging is another area where decorators shine. Here is an example. From functools import wraps. Define logget function. At wraps func. Define with logging args keyword args. Print func.name plus was code. Return func args keyword args. Return with logging. At logget, define addition func x column. Do some math. Return x plus x. Result addition func 4. Output addition func was called. So it prints something when calling the function. It prints the log when calling the function. That's awesome. And it doesn't even print the result, but it will print it. Can be used for function memorization too. Functools.lru cache, for example. Let's cheat for Lico with bad algorithm. What? Well, it can be used to function memorization. There's a lot of things in the functools. Wow, so good. But don't cheat for Lico. Actually do algorithm. Maybe one day I'll do algorithm ASMR as well. Nice. I'm sure you're already thinking about some clever uses of decorators. So 7.6 decorators with arguments. Come to think of it, isn't at wraps also decorator? But it takes an argument like any normal function can do, so why can't it do that too? This is because when you use @myDecorator syntax, you are applying a wrapper function with a single function as parameter. Remember, everything in Python is an object, and this includes the functions. With that in mind, we can write a function that returns a wrapper function. Wow, this is getting a little complicated. 7.6.1 Nesting a decorator within a function. Let's go back to our logging example and create a wrapper which let us specify a log file to output to. So we are going back to the logging example and we create a wrapper to output the log to our log file. Code block. From functools import wraps. Define logit. Log file equals to out.log. Column. Define login decorator func. Column @wraps func. Define wrapped function. Args keyword args. Log string equals to func.name plus was called. Print log string. Open the log file and append. With open log file A as open file. Now we log into the specific log file. Open file.write log string plus n plus new line. Return function args keyword args. Return wrapped function. Return login decorator. At logit, define myfunc1 pass. myfunc1 output. myfunc1 was called. A file called logout.log now exists with above string. At logit, log file equals to func2.log. Define myfunc2 pass. myfunc2 output. myfunc2 was called. A file called func2.log now exists with the above string. So we nested a operator within a function, and it is printing the logs. To be honest, I'm not completely understanding it, and I'm not trying to do this on stream. It's another homework to take a look at. Nice. Oh, and the Decorator class is coming. .6.2 Decorator classes. Now we have our logit decorator in production, but when some parts of our application are considered critical, failure might be something that needs more immediate attention. Let's say sometimes you want to just log to a file. Other times you want an email sent, so the problem is brought into your attention, and still keep a log for your own record. This is a case for using inheritance, but so far we have only seen functions being used to build decorators. Luckily, classes can also be used to build decorators, so let's build logit as a class instead of a function. Class logit object log file equals to out.log. Define init self.func. Self.func equals to func. Define call self.args. Log string equals to self.func.name plus what's called. Print log string. Open log file and append. With open self.log file A as open file. Now we log to the specific log file. Opened file.write log string plus new line. Now send a notification. Self.notify. Return basic func. Return self.func args. Define notify self. Logit only logs, no more. Pass. So we have a logit class, and it has init, it has call. And in the call, it first writes into a file and then calls the notify function. Right now the notify function is empty. This implication has an additional advantage for being much cleaner than the nested function approach, and wrapping a function still will use the same syntax as before. So you can use a class to build decorators. Now let's subclass logit to add email functionality, though this topic will not be covered here. Class email logit, and a logit implementation for sending emails to admins when functions is called. Define init self email equals to admin@myproject.com args keyword args. Self.email equals to email super self email logit self.init args keyword args. Define notify self. Send an email to myself.email will not be implemented here. Pass. So you use inheritance. I think you use inheritance to implement the notify function. すごい. From here at email logit works just like logit but sends an email to admin in addition to logging. Wait, we covered decorators. That's like one of the hardest concepts in Python. How are you feeling? Hola amigo, ¿cómo estás? Hola Alex, Avila, welcome. Thank you Jupiter for helping. Welcome Burning Star. Good night, Ice Cat. I don't mind you guys sleeping because If I were you, I'm going to sleep too, and I think that's okay. This is to help you relax, and listening to code can be pretty sleepy and relaxing. So if you fall into sleep, that's my intention too. Hola, es mi. Guión gusto. Oh. Yeah. Bienvenido en mi canal, encantado de conocerte. Bienvenido a mi canal, encantado de conocerte. Decorator is surely not for beginners. I've used decorators before but never knew how they worked, but it finally clicked and I'm playing with making them right now. Oh, nice! Sugoi, I wanna use it too. I know people who use Flask, really use it for like easy, simple authentication. I'm so glad I learned how to debug and debug with PTB, setting breakpoints today, and also how to log properly, not just print hello world like that. That's awesome, that's awesome. Yay, I'm happy that it's useful. I'm scoring for other chapters. I think Decorator was the longest chapter. I think we have done a lot today. I really learned a lot. I don't know about you guys. I'm sure many of you are experts in Python. I recently started to appreciate like reading a book. Like after I've done Linux from scratch, I realized reading a book from beginning to the end helps you systematically learn about a topic. So yeah, I think I'll do more of this reading streams where I get to learn. That's the main reason I'm doing it. And if it helps you either technically or helps you relax, that's awesome. That's awesome. Yeah. So I think I'll end the reading. Right now we finished chapter 7 and I might do it next week. Awesome. People should understand that even minor things as int float and other things are all proper class instances in Python. Nearly everything is object. Is there anything that is not object? And yeah, I'm ending the stream pretty soon, but if you have any questions, anything you want to discuss, anything you want to ask about the channel, about tech, about just how to be a VTuber, I'm here to answer for like 5 minutes or so. Feel free to throw something in the chat. I'm very happy you guys are here, and I'm happy if it helps you just a bit. I might upload a version where I have the background music from the beginning to the end. I'll try to find a pretty box to put myself in and be sad for like 1 minute because the BGM wasn't turned on today at the beginning. I do have my stream schedule prepared, but I am contacting with some people I wanna collab with to make sure the final time. So I think I will have a stream not tomorrow, but Thursday on Hack in the Box, and Saturday I am going to collab with Yumechan to read the Marshmallows, and on Sunday maybe I'll collab with Koikuma-chan again to play the DLC. I'm still like discussing with Koikuma-chan about the time we are going to continue the DLC. Yes. Thank you so much, Limit of X. Thank you for coming. So it was Yamosa. Well, finish. Oh, gracias, mucho gracias. Thank you. Oh, thank you so much, Alex. That's a very nice comment. Gracias, gracias. Thank you, Ketsuyo, thank you so much. Alright, if there's no other question, I'm going to end the stream now. Thank you for coming, Adam. I'm glad you have a bed. Thank you and good night, good morning, have a great day. See you in Discord. Yes, check out my Twitter, my Discord, my YouTube, and my Twitch. I stream both at YouTube and Twitch. Currently, at the same time, I am super active in Discord because I like fish touching and slacking. I have trouble focusing on stuff. But I enjoy coding. Hey, and I sometimes post some stuff on Twitter. I also have followers. So check it out, check it out. Thank you, Eric. Thank you, Jupiter. Good night. Stay awesome. Bye bye. Thank you, Eric. Thank you, Limit of X. Thank you, Jupiter. Thank you, Cat Seal. Thank you, Ben. Thank you, Bill. Thank you, Ice Cat. 晚安。安安 would be blowing ear if you slam a surprise cut. You made me wanna do it. Thank you, Lloyd. Bye bye, 赵小兔兔。This won't be archived. I don't know. If I have time, I'm going to re-upload the entire thing. Okay, bye bye. See you.